All right, today we're going to be looking at partial fractions and how to integrate problems using this method. We have examined integration problems like this particular one, where you have the integral of x plus 5 over x squared plus 10x plus 1 dx through using u substitution. And what we would do is we would let the denominator be the u value, and du then would be 2x plus 10 dx. Well, what we can do then is we can factor out the 2 out of that, which leaves you with x plus 5 dx. And you can see that we have the x plus 5 dx part in the problem. All we would need to do is insert the 2 and then put a 1/2 in front. And what that would give you is 1/2 the integral of 1 over u du, which then becomes this answer right here. The problem with this is that if the number 5 right here was any number other than 5, any other constant, we would not be able to do this because it would not factor down to this right here, and that would cause a problem with doing u substitution. So suppose we are asked to find the integral of this problem right here. Attempting to use u substitution with the denominator being u, it's not going to work out because du would be 2x plus 3 dx. By multiplying 8x plus 82 by a constant, it's just not going to work out because you cannot factor out and reduce down to something times 2x plus 3 dx. At this point, we would really say that this was not integratable, at least with the techniques that we have learned so far. The goal of this lesson is learning how to transform a rational expression into a sum of relatively simple partial fractions, each of which is easy to integrate. In theory, many ratios of polynomials that have a numerator of degree lower than the degree of the denominator can be written in this format, where when you have a polynomial over a polynomial, and like it said up here, the degree of the numerator has to be smaller than the degree of the denominator, you can write this out as a constant over a linear polynomial plus another constant over a linear polynomial plus, and then etc., until you are able to generate that rational expression. All right, so what we're going to do now is look at how do we actually do this using that same problem that we just looked at. So what our task here is to find the integral of 8x plus 82 over x squared plus 3x minus 10 by the method of partial fractions. The first step is factoring the denominator from x squared plus 3x minus 10 down to x plus 5 times x minus 2. And you should recognize that this fraction was created by adding two fractions where x plus 5 times x minus 2 was your common denominator. All right, so what we're going to do is we're going to write this fraction as something over x plus 5 plus something over x minus 2. And we said on the previous slide that there will be a constant on top of each fraction, so we're going to just let that constant be represented by a and b for those constants. So if you were to able to take this fraction plus this fraction, you would need to get a common denominator. So this fraction would get multiplied by x minus 2 over x minus 2 to get our common denominator. This fraction will get multiplied by x plus 5 over x plus 5 to get the same denominator. And then when you add the numerators together, that's going to generate 8x plus 82. So our task here is to figure out what is the a value and what is the b value for this particular problem. All right, so the way that we can solve this is we can multiply this whole equation by the common denominator of x plus 5 times x minus 2. The purpose of doing that is to get rid of the fractions in our problem, because this down here becomes x plus 5 times x minus 2. When you multiply, your denominator will cancel out completely, which will leave you with 8x plus 82 equals, and then on this next fraction, the x plus 5 will cancel with the x plus 5, so you will end up with a multiplied by x minus 2. And then when you multiply this fraction by this, your x minus 2's will cancel, leaving you with b times x plus 5. All right, so we have a problem here, and we want to figure out what a and b are, but problem is we have too many unknowns in this problem. So what we can do is make life easier by eliminating two of our unknowns in one fell swoop. And so let's say that we want to eliminate the x's and the b's. All right, so what we're going to do then is we are going to say, let's let x equal negative 5. So if x is equal to negative 5, and the reason I'm choosing that value is because if x is negative 5, this parenthesis will be 0, and that times b will knock out the b out of the problem. All right, so we will then be able to solve for a. So if x is negative 5, you get 8 times negative 5 is negative 40, plus 82 equals a times negative 5 minus 2. All right, so that's going to give us positive 42 equals negative 7a, giving us a is equal to negative 6. All right, so we now know what the a value is, and we can find b using a similar process. So if we want to find b, what we're going to do is let x equal a value that will knock out the a. Well, the value that will knock out this a is going to be when x is positive 2. So we let x be 2, which will make this parenthesis 0, and then 0 times a will give us 0 for this term. All right, so we're going to let x equal 2, which will give us 8 times 2 is 16 plus 82 equals b times 2 plus 7, and that's going to give us 98 is equal to 9. I'm sorry, let me back up for a second. It's going to equal 2 plus 5. So 98 will equal 7b. Dividing by 7 will give us b is equal to 14. All right, so now we can rewrite this problem as the integral of a over x plus 5, and the a value was negative 6, so it's going to be negative 6 over x plus 5 plus the b value, which is 14 over x minus 2 dx. All right, so if we do the integral of the first part of this, then you're going to take the negative 6 outside the integral, and that'll give you negative 6 integral of 1 over x plus 5, which is negative 6 natural log of x plus 5, plus, and then do the same thing with the next fraction. You'll get 14 natural log of x minus 2, and plus c on the end of that. Now, this process right here, or this method of being able to solve partial fractions, is called the Heaviside method, named after the mathematician Oliver Heaviside. All right, so the problem with the Heaviside method is it involves a great deal of writing. And so this method can be shortened down into a simpler process. All right, so let's look at the first step in this. We're going to write the fraction and the partial fractions with no numerators. So we're going to write the fraction. So the fraction was 8x plus 82 over x squared plus 3x. And actually, let me go ahead and write this in the factored form here. So that's going to be x plus 5 times x minus 2. And this is equal to something over x plus 5 plus something over x minus 2. And this says we're going to cover the x plus 5 with your finger and let x equal negative 5 in the expression. All right, so we will cover this up. So imagine this parenthesis right here not being there. And we're going to let x be negative 5 in the rest of the problem. All right, so in the rest of this expression here. What we're trying to do is figure out what number is going to go up here. All right, so when x is negative 5, cover up this parenthesis. 8 times negative 5 is negative 40 plus 82. And then in your denominator, again, this part you're ignoring. So negative 5 minus 2 is negative 7. That's going to give you 42 over negative 7, which is negative 6. All right, so we're going to do the same thing with this to figure out what number goes above this one. So in this situation, you're going to let x be 2, but you're going to cover up this parenthesis. All right, and so if you let x be 2 and cover up this parenthesis, 8 times 2 is 16. 16 plus 82 is 98. And then 2 plus 7 is, 2 plus 5 is 7, which is going to give us 14. So that is a much easier and quicker way of being able to figure out what your numerators are. And so what we now do is find the integral. And so your integral is going to be negative 6 over x plus 5 dx plus the integral of 14 over x minus 2 dx. These are much easier to evaluate, and you'll get your same answer that we had on the other page, which is negative 6 natural log x plus 5 plus 14 natural log x minus 2 plus c. All right, so let's take another problem here and see how this works out. All right, so the first thing that we're going to do is we're going to factor your denominator, which goes down to x minus 5 times x minus 1 All right, so what we're going to do now is we're going to let our denominators in our simplified answer be something over x minus 5 plus something over x minus 1 dx. And our task is to figure out what are these constants that are going to go up here. So the first thing we're going to do is let x equal 5. Since x is 5, we're going to ignore this parenthesis. So you can cover this up with your finger and put 5 in everywhere else. Well, 5 minus 4 is 1. 5 minus 1 is 4. So this would reduce to 1/4. All right, so that is going to be your numerator on this fraction. So the next fraction we're going to do, we're going to let x be 1, cover up this parenthesis, so that's going to give you 1 minus 4 is negative 3, 1 minus 5 is negative 4, so you're going to get negative 3 over negative 4, which is positive 3/4. All right, well, that's pretty easy to do the integrals of this. You're just going to get 1/4 natural log x minus 5 plus 3/4 natural log x minus 1 plus c. You can see this method of integration is really pretty easy once you get the hang of it. All right, so the next one, let's go ahead and factor first. So you're going to have 2 over x minus 5 multiplied by x plus 4. You're going to have something over x minus 5 plus something over x plus 4. We need to figure out the constant that is going to go up here by plugging 5 in for x. But because we're plugging 5 in for x, we're going to ignore this parenthesis. That's going to give us 2 over 5 plus 4, or in other words, 2/9. And then you're going to plug negative 4 in for x. And because we're plugging negative 4 in for x, we're going to cover up this parenthesis. So 2 over negative 4 minus 5 will give you negative 2/9. And your final answer then is going to be 2/9 natural log x minus 5 minus 2/9 natural log x plus 4 plus c. And the last problem here looks a little bit more complicated, just a little bit more math to go through with this. And you'll also know the factoring is going to be a little bit different here. In your denominator, you can factor out an x first, which leaves you with x squared minus 4. And your denominator will then factor a little bit further into, go ahead and write this down, x times x plus 2 times x minus 2. So we do have 3 terms this time, and so we're going to have the integral of something over x plus something over x plus 2 plus something over x minus 2 dx. All right, so for the first fraction, to find this constant, you're going to put 0 in for x. And by plugging 0 in for x, we're going to ignore this factor. So plugging 0 in for x, this is 0, 0, and 12. So you're going to get 12 over. And then plugging 0 in here and here, you're going to get 2 times negative 2, which is negative 4, which will give us negative 3 for a numerator. All right, so now we're going to plug negative 2 in for x, but plugging negative 2 in for x, we're going to ignore this term. So your denominator is going to be negative 2 multiplied by negative 2 minus 2. So that's going to give you negative 2 times negative 4, which is positive 8 for a denominator. In your numerator, you're going to have negative 2 squared, that's 4. 12 times negative 2 is negative 24. So 4 minus 24 will be negative 20. And negative 20 plus 12 is negative 8. All right, so we get negative 8 for the numerator, which comes down to be a negative 1. All right, so then the last one here, we're going to let x be 2. And so we're going to ignore this parenthesis right here. When x is 2, you get 4 plus 24, which is 28. And 28 plus 12 will give us 40. And then plugging 2 in down here, you get 2 times 4, which is 8. And that's going to give us 5. And now we can write our answer, which is going to be 3 natural log of x minus natural log of x plus 2 plus 5 natural log x minus 2 plus c. Now, one of the things you have to make sure that you are careful of, notice that these were all natural logs, and if you use u substitution, the derivative of your denominator is just 1 dx. Sometimes these factors will be written the other way around and be something like 2 minus x. If your denominator is 2 minus x, remember that u substitution needs to be part of what you do, which means the derivative of this would be negative dx. And so we would need to put a negative here and then a negative in front of your integral when you're evaluating these things. So that's something to watch out for. All right, so good luck with your partial fractions and enjoy.